When we usually do graphing, we do what's called the Cartesian coordinate system, or rectangular coordinate system. But it's not the only one out there. And so if I have this point out here, let's call it 4, 7. I'll start with numbers and then we'll just change it all into letters.
Why would you do that?
Just for the fun of it. Now to get to 4, 7, obviously you move 4 units to the right and you move up 7 units. I mean, even doing rectangular coordinate systems is probably too long. All right, so another way of doing it is, how far away is this point away from the origin? We're going to call that r for, well, obviously, radius. And what is the measure of the angle as we lift off the positive x-axis? So we can describe that coordinate instead of going, x units to the right and y units up. We can say we're going to rotate off the x-axis a certain amount of degrees, and we're going to go so many units away from the origin. And it will still describe that exact location of where 4, 7 is. All right. So how am I going to, do that? Well, that's when it becomes fun. So I'm just going to draw a subsection of the picture, just down to a triangle. And the interesting part, of course, is r over here and theta inside. We already know that the base of the triangle is 4, the height of the triangle is 7. So what we need to solve for is r. R is easy. How do I solve for r? That thingy called Pythagorean Theorem. So you go c squared equals a squared plus b squared. What's c in this case? R. So you go r squared is equal to 7 squared plus 4 squared. So r squared is equal to 49 plus 16. 65. And therefore r is equal to square root of 65, which is unbreakable. I think it's 5 times 13. 5 times 13. Okay, so the side of the
positive or negative there?
Radiuses are always positive. Yeah, good question. I always forget to say something about that pot. I get you saying it all the time, and now you're saying it. I'm like, no, don't worry about that. But radiuses are always positive. Now, the lengths of the triangle can be positive or negative, but radiuses are always positive. All right, so one of the values that we need is r equals square root of 65. That describes how far away from the origin it is. But if I drag that around, it forms a circle. What I want is just a specific point. So how do I find the measure of that angle? How do I find the measure of theta?
Sine, cosine, or something like that.
Well, I don't want to use sine or cosine because r is involved in both of them, and sometimes this will be like a decimal. I would use tangent because 4 and 7 are opposite and adjacent. So you set up tangent. You go tangent of theta is equal to 4 over 7. Oh, I'm sorry. Tangent of theta is equal to 7 over 4. Opposite over adjacent. All right, how do you solve that?
Tan inverse.
Tan inverse, so you go theta is equal to tan inverse of 7/4.
I don't have a calculator. I don't know what it is. Oh, you would.
16.3. So this is theta equals 16.3
No,
degrees.
I'm not.
60. Yeah, 60.25.
Making me scribble. 60.3 degrees. Or, now I've got to be careful with the or part of this.
There's no or.
There's no or for this one. There's a reason why, but or, remember tan inverse only gives me one of the possible answers. What's the other one? How do I get to the other place where tangent is positive? It's in the third quadrant. And it actually finishes off that line that we started here. So to get from this 60 degrees here to this angle over here, what do? It's real easy.
They're complementary.
This line is a line,
Oh,
It's
180.
180 degrees.
At 180. So sometimes,
So 240.
240.3.
you may have to add 180 to your answer depending on what quadrant your answer is in. This point is obviously first quadrant, so we're not going to add 180, we want the 60.3. But what if I had -4 and -7? It would be over here, but tan inverse would still give you 60.3. So you'd have to add 180 to get it into the third quadrant. Does that kind of make sense? So if your point is not in a quadrant where tan inverse works, you always have to add 180. We'll do another one.
Makes no sense at all.
Hmm?
Makes no sense.
Yeah, it does.
Uh-huh.
So another way of labeling this point is the square root of 65, comma, 60.3 degrees. So you say your radius first and theta second. R theta. So when we're talking about polar coordinates, we're going to be doing r theta. Technically, theta should be in radians, but we'll allow for degrees for now. But technically, theta should be in radians.
Now,
Nah.
it's going to stay in degrees.
Forever.
Forever, and that's where it's
Including on the test, it's going to stay in degrees.
All right, how about this? Convert 4, -5 to r theta, polar coordinates.
So that example.
That's just an example, yeah. Once you get used to converting these things, it's not too bad. All right, so what you do is you start with a coordinate system.
You draw a picture.
Draw a picture.
That's what I draw pictures.
I know, but that's the rest of this book. Draw a picture. Draw
So
a
it's
picture.
4 -5
4, -5 would be where?
in the fourth quadrant.
Fourth quadrant, so 4, -5 is someplace over here. So this becomes your radius. It always comes from the origin. So that's r. Which way should I draw my triangle?
You're going up.
Up.
Always
Always up.
Go to the left.
This is going to be theta, but be really careful. Theta in this case is
The right.
negative, because you're rotating down, or it's a big positive number coming around, but it's better to say negative. It makes life easier. All right, so how do I find the radius?
You draw the triangle.
I did.
Label your sides.
This side is?
-5.
Top side is?
4.
So you get c squared equals a squared plus b squared. You can change that formula into r squared equals a squared plus b squared. That's perfectly fine. So r squared in this case is going to be
It's 41.
16 plus 25, better known as 41. So you get the square root of 41. Plus or minus, but it's always going to be
Positive.
positive. All right, so the r part is going to be the square root of 41. The theta part. So the next part you set up is theta is going to equal tan inverse of -5 over 4. So it's still important to make sure you label your sides correctly. So what's tan inverse of -5 over 4?
-51.3.
-51.3 degrees. Is -51.3 degrees in the right quadrant?
Yes.
Yes. So the end of this is going to be -53.3 degrees.
You mean 51?
Dang it. I meant 51. It's Friday, leave me alone.
Okay, no class then.
Alright. Now here's one of the weirdnesses of polar coordinates. This point over here, square root of 65, 60.3 degrees, could also be, how would I say this? Add 180 to 60.3, what does that give you?
240.3.
What is it?
240.3.
240.3. If I rotate it to 240.3, we're going in this direction, right? So to compensate for that, I want my point to go over here. I'm going to make it negative square root of 65. So in other words, you can have a negative radius, just the supplement or the add a straight angle to the angle.
So when you add 180 degrees, the radius is going to be -2?
Well, what happens is you're pointing in this direction now. You're going 65 units in this direction, but you don't want to go positive 65, you want to go negative 65, so that switches you back over here. So the measure of your angle is 240.6, but because of the negative radius, you go opposite along the radius, which is very strange, I know. So what can I do with this one? Well, I could make it add 180 to negative 51.3.
128.7.
128.7 degrees, but then the radius has to become negative square root of 41. So if you see a negative r, what you could do, for instance, if I have negative 5, comma, 40 degrees, and you don't like your radiuses being negative, and technically they shouldn't be, but sometimes you'll come up with negative radiuses, is you can flip this around to be positive 5, comma, what?
You would subtract 180, wouldn't you?
If you subtract 180, you get the negative swing
220.
to it, but I would literally just add
220.
180 to it. So this would be 220.
So how would you know whether to add or subtract 180?
You really want to keep him positive.
Okay.
Because people, when they get negative radiuses, they forget to float through the origin to the other side. So if you just keep the angle where you want the angle and a positive radius, it's much easier to work with. Now that doesn't happen a lot, but it's a skill that you might want to have in the background. All right, what if you don't like polar coordinates? Well, you might want to switch them back into good old rectangular coordinates. Okay. So for instance, what if I gave you, for example, give you an angle or a point, 5 comma pi over 12. So r, the radius is 5, the angle of rotation is pi over 12. What's the location of this point? First quadrant. So if I want to switch it back, I know what this picture should look like. It's a triangle in the first quadrant. This angle is pi over 12. And what's the 5 go?
It's the
bottom?
Nope,
It's not far.
It's
it's the
radius.
hypotenuse. It's the radius, 5.
Oh, sure.
So then you have to ask, how do I find the other two sides? Well, label this side A, label this side B. How do you solve for A?
Don't know.
E squared minus c.
Cosine. So you go cosine of
A over 5?
cosine
Oh,
of,
pi over 12.
thank you, an angle is equal to A
Ratio.
over 5, adjacent over hypotenuse. All the way back to chapter 1, or chapter 2. All right, so A is going to equal 5 cosine of pi over 12, which is approximately what?
A number.
And now be careful, pi over 12 is not degrees, it's,
Ready.
you gotta get your calculators in radian mode.
Approximately 4.99999. Yeah.
4.99999.
47805.
Yeah, blah, blah, blah.
So 5.
That's interesting. I made that angle too small, I guess.
You made it 15 degrees.
Yeah, it's kind of small.
Just a little bit.
4 point, I got 4 point.
18.
I got 4.
Are you in radians?
Yeah, 4.8.
This is your calculator. I know, so you might learn how to use my calculator.
Are you in degrees?
Degrees.
Or radians?
Move it over 1. And enter. There you go. 4.8. 4.8. Approximately 4.8. So that's what you get for degrees. 4.8.
That's the displacement range.
All right, how do you find B?
I'm guessing we use sine.
I'm guessing use sine. So sine of
Pi
5
over 12.
over 12 is equal to
B over 5.
B over 5. So therefore B is going to equal 5 sine of, which is approximately
1.3.
1.3. So 5 radius with an angle of pi over 12 is exactly the same, approximately, because we rounded a bunch of things, 4.8, 1.3 in rectangular coordinates. So there's ways of going back and forth between polar coordinates and rectangular coordinates. Now, there's only been a few formulas that we've used here.
Well, you can call us from everybody.
Because basically everything's based off of a triangle.
That was fast.
So out of this triangle, you get r squared is equal to x squared plus y squared. Pythagorean. You get the angle theta is equal to tan inverse of y over x plus 180 degrees or pi when needed. That's the one you have to worry about, because tan inverse only gets you one answer, and there's always that possibility of two. From over here, you get x is equal to a cosine theta, and y is equal to b sine theta, where,
Well, wait.
oh, no. I'm wrong. Back up. Delete this. I'm wrong. I don't know where I'm getting A and B. A and B don't exist.
I was like, wait, where'd you label A and B at?
They don't. I was being silly. I was thinking of what we were doing, law of sines or law of cosines. We would have an A and a B mixed in there. This has no A and B. There we go. So x equals r cosine theta. Cosine theta, and y equals r sine theta. And that basically comes from over here. The 5 was the r. A represented x in that case, so it's x equals r cosine of the angle, and y equals 5, or r sine of the angle. So these are all the polar forms that you need to do all polar coordinate system fun stuff.
That's all we need.
That's all you need for polar coordinates.
Yeah.
Until you get to calculus. And then more fun happens with polar coordinates.
Keep reminding us.
Then more fun happens.
My summer is gonna die.
Your son is gonna die? I think you're gonna die.
I'm going to steal a couple problems out of the book.
I'll be here for you.
The next thing they do is this. Since those are all the formulas for polar coordinates, they could bring a pillow for her today.
Oh, that's right. Today is right.
Today's the D-Day for her. Or I should say S-Day.
You make videos?
S-Day.
As I said, if you watch this later.
What if I have y equals 3x minus 2? What's the graph of y equals 3x minus 2?
It's a graph.
What kind of graph?
A line.
Graph.
It's a linear
line.
graph.
It's a linear graph. Y-intercept?
-2.
-2. Slope?
3.
Which means
Go
It's-
up 3.
go up 3
over
over 1.
Or
Alright.
down 3.
So we can graph this in rectangular
Way
coordinates.
to go, Ryan.
But the goal here is change to polar form. And this is much more fun. Now, obviously, a line in polar form is not going to be good. The best things for polar form is curves, specifically circles, things that are on a circular path. Or,
Why do you always say that things that are fun are never fun?
I find it fun.
It takes us 2 hours to solve.
This one's not too bad. So what you do here is you use that junk over there to change this from xy into r theta. Alright? So what's the only thing you can change?
X and Y.
Yeah. So what's y equal to?
R
It equals to
sine
3x
theta.
minus 2.
r sine theta. So you replace the y with r sine theta, direct substitution. You get 3 times
R cosine theta.
r cosine theta. And then, that minus 2 just kind of hangs around. So now the goal is this. I want to create kind of a function where one variable is by itself and the other variable is on the other side. Kind of like y is on one side of that
Tangent.
equation and x is on the
Have to have
other.
an arctangent.
Well, we're not going to do tangent on this.
Oh.
Because then you'd have to divide by things and it gets messy. Plus, you don't want to divide by anything that has a variable just in case that variable causes a 0 in the denominator.
Oh, yeah, before you had John.
You should know
You
that
didn't
shit.
either.
I'm going to use the trick from law of cosines by taking these two pieces, the outer ones, and flipping them. Remember that one? Where negative 2 here is negative, so if I move it to the other side, it becomes positive 2. This r sine theta, if I move it over here, it becomes
Negative.
negative. So I'm going to get 2 equals 3r cosine theta minus r sine theta. The goal here, of course, is get a variable on one side that you can solve for. Well, I put all the variables on one side. Which one can I solve for, though? Get by itself.
That one, the right side.
Theta
I don't know.
or r?
R, you can take R out.
You can take r out. What about theta?
You can't take it out.
You can't take it out. So you're stuck solving for
Yeah, so say
r.
theta's connected to both cosine and sine.
And you can't unconnect it unless you do sine inverse and cosine inverse. But you can't do that to the whole thing. So.
Yeah.
All right, so solve for r. Kick r out. So you get 2 equals r times 3 cosine theta minus sine theta. There's not much you can do with 3 cosine theta minus sine theta.
You just divide that over.
And then you just divide it over. So r equals 2 over 3 cosine theta minus sine theta. In polar language is the equation of that line, and it graphs that line. Now I got to describe how it graphs it. This is the cooler part. So let's graph it. How do I graph 3x minus 2?
You plug in the calculator,
By hand. Where do I start?
the origin.
3x minus 2.
Intercept 2.
What's the y-intercept?
Negative
Negative 2, so you go down 2, here's negative 2. And then where does it go?
2. You go up 3 over 1.
Up 3 over 1, and the line goes something like that, in both directions. Okay. Now, describing how polar form works, you have to think of it as the arm of a second hand, but the second hand is actually going backwards. So, when you're at 0 degrees, you're pointing in this direction. If you're at 45 degrees, you're pointing in this direction. If you're 90 degrees, you're pointing in
Straight up.
straight up. And then everything in between, obviously. 30 degrees, 15 degrees, 10 degrees, so forth and so on. So as we're rotating this radius, the radius when theta is 0 would be right there. On that line. If the angle was 45 degrees, we'd get this point right here. If the angle was 60 degrees, we might get this point here, and so forth and so on. So as the angle opens up, you start plotting all of these points as you move up the line. It's kind of cool if you think about it. Yeah,
It's like how scissors work.
I guess you could think of it that way. Because anything that opens up like that, where it creates a gap, is a polar coordinate, weirdly enough. Alright, so lines in polar coordinates is not very powerful. Let me show you one that's really easy though.
So are we done with that, bro?
Yeah, that's it. That's the polar form of a line.
So we just
Change it
we
from
just change to R.
xy to r theta. That's all you're doing. Xy to r theta. It's kind of neat.
So did we have to plot it? Did we have to plot it? Or did
No,
we
I was just showing you how it would work in polar coordinates. Lines in polar coordinates is not worth it. Lines in rectangular systems are much easier to work with. What about this one? X squared plus y squared equals 8. What's that the graph of?
triangle.
Full circle.
It's a circle.
What?
Remember unit circles, x squared plus y squared equals 1?
Uh,
No, this is x squared plus y squared equals 8. What's the radius? 4.
8.
21?
It's 8.
It's not 8.
What?
It's x squared plus y squared equals r squared.
So that's r squared.
So that's r squared, so it's r.
2 square root of
2
2.
squared root of 2. So in this case, r equals 2 square root of 2. Alright, let's change it into polar form. What do I replace x with? What's x equal to in polars?
R cosine.
So this becomes r cosine of theta squared plus
R sine theta.
r sine theta all squared. And then it's equal to 8 because, I mean, that's the original equation. So this is x squared plus y squared equals 8.
Do
Now what?
we have to foil it out?
No, you can't FOIL. This is r times cosine theta all
Okay.
squared.
Alright.
It's not r plus cosine theta. Then you'd have to FOIL.
Alright.
So then this becomes,
2 square root of 2 cosine.
no, this.
I don't know.
R cosine squared theta.
What's r theta, r cosine theta all squared?
R cosine squared theta. R squared cosine squared theta.
First one squared, second one squared, theta. So therefore the next one becomes
R
r squared
sine squared theta.
sine squared theta is equal to
8.
8. Okay, then what?
Take out your R squared.
Kick out an r squared. Left behind is cosine squared theta plus sine squared theta is equal to 8.
So that equals 1.
You know, cosine squared theta plus sine, cosine squared theta plus sine squared theta equals 1. So you get r squared is equal to 8. Therefore, the equation of a circle in polar form is r equals 2 square roots of 2. The radius is always 2 square roots of 2. The angle can be all of them. And it forms a perfect circle. So the equation of a circle in rectangular coordinate systems is this mess up here. But if you want a circle of radius 4 and r theta, you just write r equals 4. In rectangular, that would be x squared plus y squared is equal to 16. Which one makes more sense?
The x and y to me because that's
Really?
That's how
I see r equals 4 and I'm like, oh, 4 units away from the origin.
Well, I grew up with.
I know, you grew up with
so that
this.
seems easier to me.
But I mean, writing wise, let's put it that way. Which one's easier to write?
Let's take everything you know and do this with
And
it.
just say it was a complete lie. You do it this way.
Yeah. This is how the road works.
But mathematically, the top one is much easier to work with than the bottom one. Calculus especially. How about?
No more examples.
Oh no, we got a couple more.
There's no time.
Yeah, there is.
It's 2:13.
There's no time.
It's not plenty of time. How about? There's my polar form, and I want to go back to rectangular.
What's
do
your
you think?
radius?
There is no radius. It's theta equals pi. Like here, I have r equals 4, but it forms a perfect circle of radius 4.
So
Oh, it's a circle.
This is theta equals pi over 3. What does theta usually do? Makes you
draw.
go in a certain direction, right?
It draws a picture.
Alright, so draw a picture. What quadrant is it in?
The first one.
First quadrant. So it
60
goes
degrees.
this way. But that's for positive radiuses, but there's always the possibility of...
Negative
No.
radii.
So it also goes
No.
this way.
You can't.
And this angle is pi over 3. So how do I change that into rectangular coordinate system?
Wait, what?
How do I change? That's polar form. I want to change it into x's and y's.
You draw the triangle, right?
Draw a triangle would probably be a good idea. Here's that. Call this side
Why?
y. Call this side
X.
x. And r could be anything you want it to be.
It's 2.
But it's
R could be 2, 3, 4, 5, 6,
It's
7, 8.
bananas.
I'm just going to leave it as r. Alright, so
R
if this is pi over 3, what's y equal to?
square
It's
root. 3.
Square root of 3. I don't even need to do it much else. X is equal to 1. Yeah.
And R is 2.
And R is 2.
I was right.
Oh, but this could have been 2 square root of 3. This could have been 2, and then R is 2. And R can be any length.
But
For our special triangle, it's 2.
So I just guessed. I got it right.
I swear to
Shut
God,
it
I
up
guess.
with your guessing.
So,
All I said was 2. I was like, it's 2.
okay, guess me this.
Delete that.
If this is a line,
Good.
what is the equation of the line if x is equal to 1,
Oh,
y is
man.
equal to square root of 3, and it goes through the origin?
You can't guess it.
I'm guessing it's a number.
It's an equation.
It involves
How do you find the equation of a line?
How
How do you find the equation of a line?
Y equal mx plus b?
Linear.
That's one way you could do it. Y
Linear
equals mx
equation?
plus b. Yeah. Y equals mx plus b. Or y minus y sub 1 equals m times x minus x sub 1. But this goes through the origin, so life is safe. What's the y-intercept of that line?
0.
0. So b is 0. What's the slope of that line?
1 over 3? 3?
2.
2?
How do you find slope? What's slope? Change
It's
in
2 over
1.
y over change in x. What's the change in y?
Square root of 3.
Square root of 3. What's the change in x?
So it's square root of 3.
It's square root of 3. So the slope is square root of 3. So y equals the square root of 3 times x.
See, I do that.
All right.
Mm-hmm.
Let's try this one then.
No, stop. I didn't
Theta equals 5 pi over 7. Stealing all his paper.
Yep.
5 pi over
Watch
7.
this, probably gonna ask me for a ride.
What's different between pi over 3? What?
He's like, watch this, he's gonna ask me for a ride. I
Yeah.
kinda have to since I was with him here.
I figured. What's the difference between having theta is pi over 3 and theta is 5 pi over 7?
It's not a special.
That was the
triangle.
joke.
There's no special triangle. So to do this one, we're going to have to use
Our guessing skills.
handy dandy calculator. Handy dandy calculator.
I'll just guess.
Where's 5 pi over 7?
It's in the
Second quadrant. So here's 5 pi over 7 sitting in the second quadrant. I'll draw a triangle. This is 5 pi over 7. What's the reference angle?
2 pi over 7.
2 pi over 7. So when we do our calculations, it's going to be based on 2 pi. Well, actually, with a calculator, we can plug in 5 pi over 7. That'll be perfectly fine. This side is x. This side is y, and I'm looking for
Wouldn't that be
the.
negative x? Is it going to be
Well, we'll solve for x, and it will become negative.
Oh.
It will become negative. All right. So how do I find x? Well, x is equal to r cosine theta. So x is equal to, do I know r? No, I don't really care right now, so I'll just put r.
It's 2.
It is not 2. It's not always going to be 2. Cosine of the angle. Now, if you choose 2 pi over 7, cosine in the second quadrant is negative. It's better if you choose 5 pi over 7 because that'll guarantee the calculator spits out a negative. So 5 pi over 7. Now what you could do is assume that r is equal to the easiest number in the world,
1.
1. But you could choose 2 if you want. It doesn't matter what you choose r to be. I like choosing the 1 because then you can just say x is equal to
Cosine.
cosine of 5 pi over 7, which is equal to what? Approximately.
Is my calculator in the right format for this?
You're in radians right now.
Alright.
Last time I checked.
Making sure. 0.999.
It's not negative?
Uh,
Did you? What did you get? Negative?
Why did they go back to degrees?
Negative point, I don't know.
6.2.
62?
It would be.
Negative 0.62
What?
units, I guess, would probably be the easiest way to say it. So this side here is negative 0.62. Of course, making the radius equal to 1, you're definitely going to get numbers smaller than 1 for the two sides. It gets messy. There's another way of doing this, but we'll talk about that in a second. What's y equal to when r is equal to 1? Sine of that angle 5 pi over 7. Is this answer going to be positive or negative? It's going to be positive, second quadrant. So sine of 5 pi over 7?
0.78.
0.78?
Is that right?
Oh, or wait.
My calculator went back to degrees, so I
Right.
don't know how.
Did you hit 9 and clear at the same time?
Did I hit what?
Yeah.
Point seven.
Right.
0.7.
What's an 8?
0.78? 0.78. So this side is 0.78. Now, when I let r equal 1, we're on a unit circle, right? Okay. We're on a unit circle. To find the slope of this line, what am I going to do?
Rise over.
Take y and put it over
Okay.
x. So the slope of this line is equal to y over x, which is equal to 0.78 divided by negative 0.62. Does this seem weird? That you're doing y over x on a unit circle. What's y over x?
Isn't that tangent?
It's tangent. So to find the slope of the line, all I have to use is
Tangent of the inside.
tangent.
Well,
So figure this one out first. What's 0.78 divided by negative 0.62?
Negative 1.2.
Negative 1.2.
2.6?
Okay.
2.6?
Yes.
Okay.
Yeah.
So the slope of this line is negative 1.26. Now, curiously, let's do m equals tangent of 5 pi.
I got a positive 1.26 for that one. For the tangent
you
one.
put it
That's because you're putting in 2 pi over 7. I said if you use 2 pi over 7, you have to be careful of sign, if it's positive or negative. What's tangent in the second quadrant?
negative.
Negative, all students. If you use 5 pi over 7, it'll give you the right sign. It'll give you the right sign. So if you type in tan of 5 pi over 7, it gives you negative 1.26. So a cool thing about lines that go through the origin, the slope of it is the tangent of that angle. All right, so what's the equation of that line? Well, it's going to be y equals something x, and b is equal to big fat 0 because it goes right through the origin. So what's the slope?
Negative 1.26.
Negative 1.26. And there's the equation of the line that fits theta equals 5 pi over 7. So you might want to make a side note. The slope of a line that goes through the origin is equal to the tangent of that angle. So if I have a line where slope is equal to 3/2, how do I find the measure of this angle?
You do tangent of that is equal to
Tangent of tan
theta.
tan. I don't know what theta is. Well, I can write that. Tan theta equals
R theta.
3 over 2.
3 over 2. And therefore theta is equal to tan inverse of
3 over 2.
3 over 2. So that would tell you the angle of inclination of a line. What if I wanted to go backwards? Well, if I knew what theta was equal to, this being theta, to find slope, I can say slope is equal to tangent of theta. And you're done.
What?
So the relationship between the angle and slope is direct. It's kind of cool.
So like back in high school, when we spent so much work trying to find what n was equal to, we could just, if they taught us tangent.
And you could figure out the angle and stuff. Yeah.
Here's the way caloric teaches. Okay, here's you. Here's your answer. First, we're gonna go this way, and here's your answer.
And then
But oh wait!
there's a
Then
shortcut. But I wanted you to realize that we're still using the x and y formula, but when we use them, we got y over x, which is the same thing as tangent. So, I mean, if I went in any other direction, you'd have been like, oh,
Well, if you did the shortcut and then later on be like, so if he actually just did the work, it'd be y over x, which is tangent. And just say it, don't show it.
I like showing it, I'm sorry. How about, what's worse? Something worse. Ooh, that one's good. This is 64.
Yeah.
R cosine theta is equal to 7.
sorry.
Actually, this isn't worse. This is actually kind of easy.
Sorry.
Sorry, what?
What is this thing in terms of x and y?
So we define x
Well.
and y.
R cosine theta is
Well, isn't
y,
that isn't that x?
R cosine theta is
That's
x. So this turns into x equals?
7.
Done.
Bruh.
Gotta find something harder.
It's so simple.
How about this one then?
So simple.
66. R equals
Slide away, dude.
6 secant theta.
Totally.
I'm always curious.
Why would you do, no, why would you?
What, secant?
Now we got converted into like all this
Sine,
whatever,
cosine.
whatever cosine.
Alright, so this becomes R is equal to?
Oh my god.
6.
Over
1
Cosine?
over
cosine.
I was right.
Now
That's
what?
it.
Multiply cosine to the other side.
Oh no.
So you get R cosine
So it's gonna
theta.
give you x is equal to 6.
So this becomes x is equal to 6. See, not that bad.
So in the shortcut way, if you see 6 in front of the secant, you can just say, oh, it's x equal to the number in front of secant.
As long as it's equal to R. Some of these equations will be R squared equals. So you gotta be able to.
Well, then you just wrote it.
How about
Shortcuts.
This one.
In high school.
this is 72?
I say Rousing will teach you the shortcuts.
R equals 8 cosine theta.
Kirk will teach you everything. She teach you everything and nothing.
Our math teacher from high school. It's,
Miss Kirk,
yeah.
So what do I do here?
wife of Captain Kirk.
You get to take out something to make it just cosine and sine, right?
they're at it too.
I'll give you another suggestion.
You can multiply the 2 by 4.
You have to have this. You either have to have R times cosine or R times sine. If it's missing, there's really not much you can do with that. So guess what you're going to have to do to that to get R involved with the cosine and the
X
sine.
is 8, y is 2.
Take 1 over to the other side.
Take R to the other side? I need to be R times cosine. R
So
times.
take the cosine
What
to
do you
the
want
other
me to
side.
do?
It's an equation. You could do whatever you want to one side as long as you do it to.
Oh, okay. So now we can manipulate both
Okay,
sides.
let's go back to identities. If something is missing, throw it in. What's missing?
A cosine.
I got a cosine.
So it's missing an R.
I'm missing an R. R cosine specifically. So how do I make it so it's R cosine?
Throw in an R to both sides.
In what operation, please?
Multiply by R.
Multiply both sides by R. So if I
So we get
multiply
R
both sides by
squared.
R, totally legal with an equation.
R
not
squared.
And R
identity.
squared is equal to 8R cosine theta plus 2R cosine theta.
8R cosine theta plus 2R sine theta. Okay.
Now what?
Now what?
Well, why did I want R cosine theta?
Because you told us.
You said it.
Why did I like it over there?
Because you
That's our
solve
X
easily.
or Y value.
What's R cosine theta equal to?
X.
X. So I can take R cosine theta and replace it with,
X.
and R sine theta and replace it with.
Y.
Alright, so this becomes,
R squared is equal to 8x plus 2y.
alright, once I change this side into x's and y's, I do not want to write R squared on the other side.
You can write c squared.
So what's R squared equal to in terms of x and y? Go back to those formulas of polar coordinates. It's the only ones you get.
Say that one more time.
I want R squared in terms of x and y.
It's equal to x squared plus y squared.
So this becomes x squared plus y squared is equal to 8x plus 2y. Great. What is that?
Whoa, no. I don't like this.
What can I do with that?
Oh, who you gonna complete the square?
Eventually.
What?
I gotta move everything onto one side
And equal to 0.
and get it equal to 0, so it becomes x squared minus 8x, leave a space,
Minus.
plus y squared minus 2y, leave a space, is equal to
Oh no, not that.
0.
Are we using the like the perfect square form or whatever?
Yeah, she
No,
said that already.
I don't like that.
Ah, it's a wonderful formula.
You take half that and square it or something?
Yep.
So half of negative 8 is?
-4.
Negative
so
4.
plus 16.
Square it, you're going to add 16. If you add 16 to the left,
I did not.
What?
What the heck? If I add 16 to the left,
Add it to the right.
add it to the right. See, you remember this stuff. Half of -2,
It's just gonna be 1.
-1. Square it, it becomes.
I'm talking about like, let's do it. What's gonna be 1?
This is more important for our next step. And then the 1 over here is kind of important too, so make sure you add it to the other side.
I said it's gonna be 1.
As a perfect square, what is this one?
It's x minus 4.
Yeah, it's that number that we took half of. So this is x minus 4 squared
That's
plus
minus 1.
y minus 1 squared is equal to,
17.
what's the center of the circle?
4, 1.
4, 1. So center, 4, 1. Radius,
17.
Square root of
17.
square root of 17.
Is it positive or negative?
So r equals 8 cosine theta plus 2 sine theta is the same thing as a circle centered at 4, 1 with a radius of square root of 17. So out of all of this, 2 things you're going to be looking for. If you have a cosine theta by itself, you really want an r in front of it. If you have an r, you really want an r squared, because r by itself doesn't tell you anything, but r squared is x squared plus y squared. You can manipulate these things because they are equations. So if you're missing something, multiply both sides by it.
So now we can mess with both sides.
Oh yeah, this isn't identity stuff anymore. These are pure equations. How about this one? This is 74.
I'm gonna just do the first. How many questions on the exam?
2,000.
25, right?
I'm gonna just do the first 12 and say bump it.
Are you talking about the final exam?
Bump it.
Oh, I don't know how many on that yet.
You
All
said
right.
it was 25. I asked you.
Oh, did I?
Yeah, I asked you earlier this week.
I said 25, 30.
No, you said 25.
25, 30.
You said 25.
How about 20?
What can I
It
do?
was on camera.
Oh, fine. I deleted that. You gotta get me to put it in writing.
Well, come right now.
Now we gotta use that double angle.
Woohoo! So the double angle identity for sine of 2 theta.
That's right, because it's 2 theta. Great.
Oh, just cosine.
No.
Oh,
Sine 2 theta.
John, where's your sheet?
isn't it sine, cosine,
It's sine cosine
too.
side by side,
with a
square?
2?
2 in front of it.
Oh,
With a 2 in front of it. So this becomes r squared times 2 sine theta cosine theta is equal to 4.
Mm-hmm.
That's legal.
So wait, hold on. It's r squared times what?
2 sine theta cosine theta is the same thing as sine of 2 theta. That's that identity fun stuff. Now, remember,
It's legal.
you want to get back to r cosine theta or r sine theta.
Mm-hmm.
So how do I get r cosine and sine theta out of this mess?
Lord, have mercy.
It's not that hard.
What are you doing? I said
I need an r cosine theta, I need an r sine theta.
just distribute it.
Distribution is only over parentheses with a plus or minus in
We'll
between.
multiply it out.
It is multiplied out.
Then why do you have the little dot there then?
That's multiplication. This is r squared times 2 times sine theta times cosine theta. You want to put all the dots, I'll put all of them. What can I do with r squared?
Take it out.
Put it over
Put
the
it
other
on the
side.
side.
You want to divide r squared on both sides?
No.
I want an r cosine theta and r sine theta.
So you take out the 2.
What does r squared really mean in math?
It's
Just
equals to
2
x squared plus
No,
y
no,
squared.
no. R squared. I don't know.
R times R.
R times r. So what if I write this as r times 2 times sine
So you
theta
just throw it in front.
times cosine theta is equal
You
to
write it
4.
as 2 times R times sine.
2 times r times sine theta.
Mm-hmm. And R times cosine.
R times cosine theta is equal to 4.
Mm.
What allows me to do that? Well, if you take 2 things that are under multiplication and switch their order, what operation is that?
It's still the same thing.
Commutative.
So because it's all multiplication,
I
it
can
does not
flip.
matter what order it is.
Right.
Because when you get the final answer, it's the
It's
same
still the
thing.
same.
Right, because you're just multiplying a bunch of numbers together.
You just
It's the
can't,
commutative property of multiplication. 2 times 3 is the same thing as 3 times 2.
you just can't do that with subtraction and division.
Well, you can't do, subtraction and division are the only bad ones.
So you can't, so even with subtracting, and even with adding,
Adding, you
subtracting,
can switch the
Adding can
order.
do it.
Subtraction, you can't.
one,
Ah,
The difference.
seriously.
Let's say 16
5
minus
minus 2.
It's 3.
2 minus
4
5.
is -3.
It's just a negative number, but it's still
Different answer though.
It's still a 3 though.
Absolutely yes. Alright, what's r sine theta equal to?
Y,
So this is 2 times y. R cosine theta
X,
is all equal to 4. So the last thing you have to do is solve for
Four.
Or x and y.
solve for y. So
Okay.
y equals
4 divided by 2x.
better known as 2 over x.
24.
Do you know what the graph of this looks like?
Wrong.
Really?
Um,
X cannot equal
it cannot
0,
be
so you get a vertical asymptote at 0. And the rest of the graph looks something like this.
Do we have to know that?
Well,
Do we have to know that stuff?
It's just stuff that you keep in your mind for a little while.
They're done now.
You never do rational graphing in 171?
No.
Yep.
Well, I don't remember.
I don't remember.
I don't remember.
You're like a police officer. I don't remember.
My dad's a cop.
I don't remember. I have no recollection.
it was a blur.
Ah,
What you trying to say?
what am I trying to say?
Yeah, my dad's a cop. What you trying to say?
Trying to say people lie to cops and people lie to teachers.
Oh, I thought you said like police officers say that. I was
No,
like,
no,
what
no,
you
no,
mean?
no, no. When you're in front of a police officer and they're asking you a question, you're like, no, I don't remember.
Oh,
Do you remember that bum that was in the street that got shot? No, I saw that.
Remember that from the movie?
I didn't see a thing, even though I stood there and watched it. My eyes were open, but I didn't see
I mean, there was
anything.
2 cop cars that rolled down the window and told him to stop, and he like put his hands up and he was like talking to them, and they put his hands behind his back, and when they left, he just kept going back to doing what he was doing. And we thought that they were gonna come back around and come get him, and we sat there and waited for them, and they didn't come back.
They never came back.
When this girl on my Facebook page, she had she took a picture of everything in her house. And I had called my cousin, I was like, girl, I see somebody gonna break into her house. How about yesterday she posted that somebody broke into her house, and
Why
I was
would
like,
she
good
do
enough
that?
for you.
Hey, look what all I have!
Exactly,
Take
that
it.
was stupid. I mean, she posted
Especially
every
with
last
all-
one of her rooms.
Especially on Facebook now, how you can like add in like where you are.
Yeah.
Yeah.
And stuff.
It was
And like
crazy.
you can add your location to your status, like where you made your status at.
Cause I had just.
And,
Come kill me, I'm here.
That's like Craigslist advertisement right there.
Alright. Back to this. I want to convert this into polar form. We're almost done.
Good enough time?
I got plenty of time.
He said it every day.
I got plenty of time. I got to bake up time. Alright, so what should I do first if I want to convert this into polar form?
Polar form. Well, converted to R and theta.
Well,
You wanna jump right
substitute
into
X
it?
and Y.
I can substitute an x and y right now, except for one problem I don't like is this.
Because it's
It's
2
perfect square, right? I highly
Yeah.
suggest you multiply this out first. Well, what's x minus 2 all squared?
X squared minus
minus
4x
4x
plus 4. I guess.
Plus y squared is equal to 4. And what's nice about that is now that those 2 4's are going to go away.
Poof.
So we're left with x squared minus 4x plus y squared is equal to
Zito.
0.
Zito.
Now do your substitution. So x gets converted into,
R cosine.
oh, even better, I'm sorry. You could do that,
Is it R squared cosine squared?
but x squared and y squared equals,
R squared.
so you could go the other direction. You'll get r squared cosine squared theta plus r squared sine squared
So R squared
theta,
minus 4x.
but you'll eventually just get to r squared. So that becomes r squared minus 4, substitute the x away. What's x equal to in this case? What's x equal to?
Hold up, wait a minute.
Oh.
What do you mean what's x equal to?
Well,
What
I
is-
changed
R
x squared
cosine.
plus y squared into r squared.
Yeah.
I can't put x and y here.
R cosine.
R cosine.
R cosine theta.
Oh, okay.
Once you start changing it into polar form, you cannot have a mixture of x, y, and r, or x, y, and theta. It just doesn't make any sense. Solve for r, and you get r squared is equal to
4.
4r cosine. Uh-oh, I can't do that.
Ah! Ha ha!
So what else can I do?
I knew it.
Dang,
Huh?
I can't do that. I have r on one side and r on
Yeah, yep.
the other. I want r's on the same side. So what's another option?
Factor in R.
Factor out an r. You get r times r minus 4
Cosine theta.
theta is equal to,
Zeta.
so this becomes like a
Zeta.
quadratic. R is equal to,
Zeta.
that's one possibility. Now, what does r equals 0 represent? It does represent something.
The origin.
The origin.
Oh,
Theta equals 0 represents the x-axis, but r equals 0 is the origin. The other formula we're going to get out of this is r minus 4 cosine theta is equal to 0. Therefore, r is equal to 4 cosine of theta. And that's the more interesting one.
So that's the answer to that.
How do I graph this?
You plug in the calculator.
No. Actually, your calculator does not like circles.
You draw a
You can
picture.
do half a circle, not a
Really?
whole circle,
Why can't we do the whole circle?
because it's not a function. Remember, functions, for every x there's one y. If a circle, you have one top and bottom.
Then I'm gonna make a calculator that can do circles.
Well, there are ones that
Graphic
do what's
calculators.
called implicit graphing,
And that one.
but yours doesn't. Or
Oh, of course not this
the
one.
big ugly one doesn't.
no.
All right, so how do I graph x minus 2 all squared plus y squared equals 4? What's the center?
2, 0.
2 zeta.
Which is over here. What's the radius?
A.
Two.
2.
2. So the circle goes that direction and then wraps around. So under polar form, that circle looks like r4 cosine theta. Now, my guess is this. What do you think r4 sine theta looks like? What do you think r4 sine theta looks like? If r4 cosine theta is to the right,
Too low.
It's
Two.
bottom.
Oh.
up. Because as sine gets closer to pi over 2, sine of pi over 2 is equal to 1, which makes it the maximum height. So this graph is going to be 0, 2, radius of
Forgot I had one.
2. So that would be r4 sine
You
theta.
get your knuckles.